It is this one? Okay. Yes, my family name is Moon, but I'm working on asteroid. Okay. Currently, we have more than 11,000 NEAs in the MPC catalog, but at the survey effort has been mainly focused on the discovery. So most objects are known only for their orbits. That's why only a small fraction is physically characterized. Oops. Okay. To date, about 8% is known for their size, yet 5 to 6% for taxonomy and spin periods, respectively. However, less than half of it is known for taxonomy and spin period at the same time. One of the efficient solutions for this, next please. One of the efficient solutions for this is 24-hour time series photometry with a set of broadband filters. Then we obtain optical size, spin states, and we can reconstruct shape model. At the same time, we can classify approximate surface mineralogy based on their broadband colors. Next, please. For decades, there has been an issue in the annual community. That is, we don't have any dedicated telescopes in the southern hemisphere that we lack of global coverage. Next, please. Now we are building an array of 1 meter class wide field telescope in the southern hemisphere in the CTIO Chile, Sutherland, South Africa, and the last one in Siding Spring, Australia. This network of optical telescope is called KMTNet, and the primary science of this network is exoplanet search using microlensing event. Next, please. In order to find exoplanets, they will point the telescope toward galactic verge in winter in the southern hemisphere when it is above the horizon. During the off-season for exoplanet search, KMTNet will be devoted to several secondary science projects, including Deep South, the Deep Ecliptic Patrol of the southern sky. Next, please. Each KMTNet telescope is consisted of 1.6 meter prime focus optics and an equatorial mount. The camera is 18K mosaic CCD made of 4 19K CCD chips. It is known as one of the world's largest mosaic CCD at present. The plate scale is 0.4 arcs second per pixel, and the resultant field of view is 4 square degrees. In Chile, we are going to use Johnson-Cousins BVLI and Sloan bands. However, in South Africa and in Australia, we'll use mainly BVLI filters. Next, please. The primary goal of Deep South is physical characterization of kilometer-sized NEAs. The project period is from 2014 to 2018. And we are glad that we awarded 45 full nights for telescope for each year, and hence 135 full nights for network per each year. Next, please. We team up with Amy and James at JPL and Steve Larson of Catalina Sky Survey. And we also have conversation with LCOGT for follow-up of new discoveries. Next, please. Deep South has 3 observation modes. OC, the opposition census, is pointing mode focused on photometry of objects at opposition. SSS, the sweet spot survey, is blind scan mode in search for Artans and Artiras in the morning and in the evening sweet spots. TO, the target of opportunity mode, will be devoted to space mission targets and high priority objects for follow-up. Next, please. Some scientific cases for the Deep South project. Next, please. Its rotational period distribution of 280 kilometer-sized NEAs. You may easily see that most of the objects have period less than 10 hours. Of course, there must be observational bias towards the longer periods. Next, please. In a single site, it's difficult to measure rotational periods longer than the night. Further, in case where it is earliest with 24 hours, the Earth's rotation period, we cannot obtain accurate value. With OC mode, we obtain densely sampled light curve, whereas SS mode, we can have sparsely sampled long duration light curve. Based on these light curves, we can get spin periods, direction, and shape model, and we can investigate binarity of the objects. Next, please. Yeah, this is a nice example of light curve constructed by 24-hour continuous monitoring of an asteroid called Moskva. It is a member of Maria asteroid family at Turkish National Observatory and Mount Lemmon in Arizona, and the other 1.8 meter telescope in Korea. It is considered as a typical light curve that will be obtained with KMT-net. Next, please. Now, comet. Comet reservoir will remain as one of the least known sources of NEOs because nearly isotropic comets are believed to evenly distributed with respect to the ecliptic, and most of short period comets is found at lower ecliptic latitudes. KMT-net is expected to cover this considerably undersampled region in phase space. Next, please. Well, the Deep South already came on the scene in the soap TV called The Man from a Star in Korea. The left, yes, this guy was in the drama is an alien who visited the Earth by a terraformed asteroid comet called Deep South. Actually, I consulted this our primetime popular TV show for 2 years. Next, please. Scheduler and pipeline. Next, please. For kilometer size NEA, we have 31 objects with pole orientation. Next, please. And we have 160 NEAs with unambiguous periods. It's nicely fitted light curve you see. Next, please. And we have 71 objects with incomplete coverage. However, we can calculate their period. Next, please. We have already implemented and are now using an asteroid observation scheduler called SMART. It automatically updates annual catalogs, generates ephemeris, and prepares target lists and sends a suite of scripts to the site operators in the 3 sites in the southern hemisphere. Yet flagging and determination of additional follow-up remain as human labor. Next, please. Now, pipeline. We've also implemented and using asteroid spin analysis package called ASAP. It is designed to conduct photometric analysis in a semi-automatic mode, so it aids to find comparison stars, derive light curves, calculate periods, and slope parameters. However, spin parameter and shape determination remains as a manual process. Next, please. We are now working out observing strategy. Next, please. It is instantaneous sky projection of NEAs in the ecliptic coordinates at CTIO on September the 1st, 2014. Red and green dots represent kilometer and sub-kilometer sized NEAs respectively. The signs indicate their apparent magnitude. We counted number of objects in opposition and in the morning and evening sweet spots. Next, please. It is number distribution. Can you see that? Wow. It is number distribution of kilometer and sub-kilometer NEAs in 6 by 60 degrees beams in the morning sweet spot in either side of the ecliptic. The red beams are kilometer size and blue for the sub-kilometer, and the total box size is 30 by 30 degrees in either side of the ecliptic longitude and latitude. Next, please. It is the same figure for evening sweet spots. And next, please. An opposition on the same night at CTIO. Although we are planning to concentrate on opposition in spring and autumn, when we have longer night, we'll conduct time series observation near sweet spot where we carry out simultaneous photometry of objects within apparent magnitude range with reasonable signal-to-noise ratio. Next, please. Follow-up astrometry and photometry is important for space missions, especially for IR space telescope, because simultaneous measurement of albedo, either in optical and IR regime, at the same phase is crucial. As we point the telescope towards a position, at the same time we could follow up the NEWise objects. Next, please. We are going to use all CAMTINET mover data for analysis. It's a sister project of Deep South called SuperTramp, the Southern Hemisphere Trackley Mining Project. This is SuperTramp, one of my favorites. Next, please. In summary, we investigate various physical characteristics of small bodies, including NEAs, such as orbit, size, surface mineralogy, spin state, and shape. It's important in terms of science, however, at the same time, the Deep South is considered to contribute to risk assessment, human exploration, and utilization. Next, please, is the last slide. Is a timeline of the CAMTINET project. CAMTINET CTIO station was already built, and the 18K CCD will be installed in the end of July, and will start operation in mid-August at CTIO. The second telescope will be completed in September, and the third is in coming November. Thank you.
Do you have time if anybody has a question? All right, then I guess we'll wrap up and thank our speaker again.
Thank you.